Hello. Today we're going to be talking about dimensional analysis. Now most of you who used dimensional analysis when you studied chemistry, and what dimensional analysis generally is when you take units and you convert them from one type of a unit into another unit. So for instance, you might be working with meters per second and you want to convert it to feet per second. We also use in physics, we use dimensional analysis to double check your answers. So for instance, if you've been given an equation and you know that you're trying to find meters, when you use the units, you can find out if you end up with meters, then your answer is correct. So it's a way to double check yourself. What we do here for dimensional analysis is we do algebra just using units instead of numbers. So here's an example. How many seconds are in a day? Okay, so over here we're going to start with 1 day. And what we're going to do is we're going to take that 1 day and we're just going to multiply it by 1. So any number multiplied by 1 is itself. So what we're going to do is 24 hours is 1 day, 60 minutes equals 1 hour, 60 seconds equals 1 minute. So these are actually multiplying by 1. So if we take 1 day and we multiply it by 1, take 1 day and multiply it by 1 and multiply it by 1, we still have an equivalent of 1 day. So over here, now this should be day. Okay, so if I have 1 day over 1 day, it crosses out. And hour over hour crosses out. And minute over minute crosses out. And so then I can do the algebra. I can say 1 times 24 times 60 times 60 divided by 1 times 1 times 1 times 1 equals 86,400 seconds. So 1 day is equivalent to 86,400 seconds. Okay, here's a little bit more of a complex problem. If you're driving 15 miles per hour, we want to find out how many feet per second are you driving. So what we're going to do is we're going to start off with 15 miles per hour. One of the things I just want to emphasize is when we talk about miles per hour, sometimes you'll see it written this way too, 15 mph. And this is probably something you see familiar on the side of the road. This is your speed limit sign, mph. The P stands for per, and really per is miles per hour. So just like here, it's really a division. So if we have 15 miles over 1 hour, what we're going to do now, this time we're going to be converting the miles as well as the hours. We're converting miles to feet and hours to second. So we're going to start here with 15 miles per hour and we're going to multiply it by units of 1. So 1 hour is over 60 minutes, 1 minute 60 seconds, 5280 feet equals 1 mile. Right here we're going to say that miles is going to cross out over here. Minutes over here is going to cancel out to here. Oh, the miles over here and the hour and the hour. So we're going to do 15 miles, 1 hours are going to cross out, 60 minutes, 1 minute, 60 seconds, and what we're left with is feet and seconds. Okay, so then we're going to multiply all the way across. 15 times 1 times 1 times 5280. We're going to divide by 60 times 60. We end up with 22 feet per second. Another way that we're going to use dimensional analysis to verify that our units are correct. So here's an example. Verify that this equation, and this is just going to be a physics equation, and you're going to see this later on, but right now I'm just going to give it to you. Distance equals velocity times time plus 1/2 acceleration times time squared. We want to make sure that we have the correct units. So what we're going to do is we're going to use these, we're going to solve this equation using units. So we said that distance equals, well, the units of velocity is meters per second. Right here, and this is a given. So we have here, we're going to say meters per second. And we're going to multiply it by time. Well, the units of time is seconds. And then we're going to do plus 1/2 A. Well, the units of A is meters per second squared. So we have meters per second squared times T squared. And the units of T, time, is in seconds. So we have seconds squared. And then what we're going to do is we're going to do algebra using units. Well, seconds over seconds cross out, and seconds squared over seconds squared cross out. So we end up with meters plus 1/2 meters. Well, if I have a meter and I'm adding another meter, really I end up still in the units of meters. So distance is measured in meters, and right here it says distance is measured in meters. So this proves, yes, we verified that this equation has the correct units. Okay, now we're going to talk a little bit about significant figures. You guys probably are very familiar with significant figures when you've been studying chemistry last year. So a little bit, some of the rules might be a little bit different. In physics, the big thing is that we use significant digits to measure the degree of accuracy of a measurement. So for instance, if you're not doing anything measured, you're not measuring in any evaluation, then there's no reason to use significant digits. For instance, money. Okay, if I have $5, there's nothing but $5 there. I can't assume it's not measured and maybe I really have $5.50. We know when you have $5. Another thing would be if we're doubling something. We're multiplying it by 2. Well, that 2 is not a measured quantity. What we're doing is we're measuring it by a magnitude. So that is not a significant, does not have significant figures. So here we use significant figures to give the degree of accuracy in a measured number. It's also the digits that are known with certainty plus the first digit that is uncertain. So for instance, if we're going to be measuring the length of something, we might be sure to this value, but we're a little bit, do we really know we're not at that next level of measurement or not? So that would be our guess. So we're going to be talking about what we're certain to. So the first digit to what we're certain, and then we're going to add a guessed value. So we might say, oh, well, this is definitely 5 meters. Well, we could be plus 1 centimeter. So it would be, 5 meters and 1 centimeter would be our uncertain amount. So there's a couple rules that we're going to deal with. There's 4 main rules for significant figures. First one is always the easiest one. These are all non-zeros are significant. So for instance here, we have the number 523. Well, there are no zeros, so all of those digits are significant. So 523 has 3 significant digits. Okay, number 2, the zeros at the end of a number and to the right of the decimal place are significant. So if this is our decimal place, then to the right is going to be this way. So we're talking about these zeros here. So these zeros are significant. So this is 57.00. Altogether we have 1, 2, 3, 4 significant digits. This one also, these zeros are significant. So they're measured values. They just have the measurement of 0. We're right on the marker. So this one has 1, 2, 3, 4, 5, 6 significant figures. Rule number 3, the zeros at the end of a number, but to the left of the decimal, are not significant. So it's really hard to see. Well, you look here and there's no decimal place. Really, the decimal is right here. Okay, so these are zeros that are at the end of the number, but to the left of the decimal place. So these ones are not significant. So the number 1000 has only 1 significant digit. The number 20 has 1 significant digit. And then our last rule here, that the zeros in front of a non-zero are not significant. So right here, we're going to be talking about these numbers here in front of a non-zero are not significant, okay? So we have numbers, we're going to be taking 2 things into consideration. The number here is the decimal place. The numbers to the left of the decimal are not significant, but here the zeros to the right of the decimal are significant, okay? So these ones are significant and this one is not significant. So in this case, this one has 1, 2, 3 significant digits. This one has 4 significant digits. Okay, so what we're going to do here is look at these problems right here. So your best bet right now is to pause the video and try these on your own and then come back and see if you're correct. Okay, so here, The decimal place would be right here. So now we're going to be looking at, let's see, rule number 3, that the zeros to the left of the digit are not significant. So we're talking about these two zeros. In this case, it only has one significant digit. Okay, this one's going to have a combination here. We have the zeros to the left over here, but we have a digit over here that is significant. So altogether, this one's going to have 1, 2, 3, 4. Okay, this zero here is not significant, but these ones are. So we have 1, 2, 3, 4. Okay, this one here is really easy because there's no zeros here. So all of those are counted. 1, 2, 3. We have 3. Okay, what about this one? This is the zero that we're concerned with. Well, there's no decimal place, so if there was, it would be here. And this would be rule 3 as well, that the zero at the end of a number and to the left of the decimal place is not significant. So this one is going to have 2 significant digits or significant figures. Okay, now this one has a combination because we have this 0, we have these 2 zeros, and this 0. So we're combining all of the rules. So rule number 2 says the zeros at the end and to the right of the decimal are significant. Okay, so these 2 are significant, and this one is significant because it's to the right. This one is to the left and is not significant. So altogether we have 1, 2, 3, 4, 5 significant digits. Okay, and over here the same thing. This is significant because it's at the end and to the right. So altogether we have 1, 2, 3, 4, 5, 6 significant digits. This one, once again, is easy. There's no zeros, so we have 1, 2, 3, 4, 5 significant digits. Okay, over here this is not, these are, this is, we have 3, 4, 5, 6. And in this case, this is, and these are in between, so they are counted. So altogether we have 4 significant digits. Okay, now let's talk about adding and subtracting significant digits. So this would be important if we were measuring, say, the perimeter of something. So we're going to measure one side right here, and that is a measured value, so we would be interested in significant digits. And then we would measure this side, and then to find the perimeter, we would add this plus that here. So when we add significant digit, the key thing is the number of significant figures in the result cannot be greater than the least number of significant digits in the input numbers. So pretty much you find out the least number of significant digits and your answer has to be that same number. Okay, so example 4. This one right here has 3. This one here has 1. And so our answer can only have one significant digit. So the key thing here is you're going to add like you normally do. You can just plug this right into your calculator. 4.60 plus 3 is 7.60. Now your calculators do not do significant figures, so what we're going to have to do is 7.60 can only have one significant figure, so we're going to have to round it up into 8, and so in this case we only have 1. Example number 5. We have 200. Now this only has one significant digit, so our answer can only have one sig fig. So 200 minus 87.3, we're just going to use our calculator and we're going to get an answer of 112.7. Well, the answer can only have one significant digit, so what we're going to do is we have to round this to one significant figure, which is just 100. And this is our one significant figure. Example 6. We have 71.86 has 4, 13.7 has 3. Our answer can only have 3 significant figures. So we're just going to use our calculator and do the subtraction. We end up with 58.76, which has 4. So we have to cut it off at this point. Well, we're going to round it up. Because this is a 6, we're going to round this to an 8, and we're going to have 58.8, which is 3 significant figures. Okay, so our next step that we're going to be concerned with is multiplying and dividing sig figs. So one of the ways that we multiply and divide in mathematics, the way that we're going to do this in physics, is that we might be taking the area. So the area this would be measured and we'd multiply it by that side. Both of them would be measured. So the same rule applies when we're multiplying and dividing significant figures as when we're adding and subtracting. So the answer, the result, cannot be greater than the least number of sig figs in the input numbers. Okay, example 7, 13.7 times 2.5. This has 3 sig figs, this has 2 sig figs. When we multiply them together, we just use our calculator. We have 34.25. And this has the least amount, which is 2 sig figs. So what we want to do is make sure our answer only has 2 sig figs. So we're going to round, and our answer ends up to be 34. And our last example for tonight is example 8. We have 5,000, which is 1 sig fig. And we're going to divide it by 55, which has 2 sig figs. So we're just going to do the division on your calculator, and we end up with 90.90.90.90. Well, we can only have 1 sig fig, so we have to end it right here. And so if we were to round it to 91, 91 has 2 sig figs. Our answer can only have 1, so 91 then is rounded down to 90, and this only has 1 sig fig. Okay, well that's enough for the lesson. We'll see you tomorrow in class.